In this tutorial, I will do number 4 from the application problems packet, and it says write an expression for the area of a rectangle whose perimeter is 100 inches, where x is the length of one side. Graph A of x, and then among all rectangles whose perimeter is 100 inches, find the dimensions of the one with the maximum area. So again, we're going to start like we did in class with the given. So the given information is that the perimeter is equal to 100 inches. And the unknown is the maximum area. And we're going to let x represent the length of one side, and we're going to let a represent the area. And now we're going to draw a diagram. So we have a rectangle, and we know that one side is x. Since it's a rectangle, the opposite side is x. Now we know that the perimeter is 100. And so from this 100-inch perimeter information, we need to come up with an expression for the other two sides. So if you think about it, the perimeter is equal to the sum of the sides. So we'll call these we'll just call these z for right now, the other side. We're not going to need that in a minute. So we have 2x plus 2z is going to equal 100. And some of you could probably figure out what z is without going through these steps. But if we subtract 2x from both sides, you're going to find that 2z is equal to 100 minus 2x. Divide both sides by 2. And z is going to equal 50 minus x. So these two sides are 50 minus x. That's the picture. Now, the area on the inside here is equal to length times width. So this is the equation. And so we have the given, we have the unknown, we have the equation, and now we're going to substitute and solve, and I'm going to go on to the next page to give some room. Okay, so this is where we left off, and the area equals length times width. That's the equation. From the guess model, the equation is that we need to find the area is length times width. So now we're going to plug in. So the area of this rectangle is going to equal x times 50 minus x. And the question asks us for the maximum area that we can have. So now we're going to go to the graphing calculator and we're going to use the graph of this function. This area, this is like having y equals x times 50 minus x, right? But instead of y, we use area, and area is a function of x. There's no difference between these two expressions. The area as a function of x is just replacing what we're used to seeing as y. So plug that into your graphing calculator, y equals x times 50 minus x. You don't even need to simplify it. You can just plug it in like that, but we know that the y-axis is really the area. So I'm going to take a picture of my calculator when I do this. Now I can see that there's some little thing on my calculator here. There's some function here, but this is a zoom standard. This is a minus 10 to 10 window and a minus 10 to 10. So that's not helping me very much. I'm not going to be able to find the maximum area. It's somewhere up here off my window. I can't see it. So I'm going to zoom out, but let's think about what would be a reasonable zoom out. If we zoom out on this type of problem, there's a couple of choices. We can try to figure out, well, what are reasonable values for x? And we could say, well, we know, well, x can't be less than 0 because I can't have a side that's less than 0. And the biggest length, if the perimeter is 100, then the biggest length has to be less than 50. Otherwise, if you had x is equal to 50, right, and this was equal to 50, then you wouldn't have anything left for these sides. So the biggest x value would be that x has to be less than 50. So we could start to build the window, and that's how you would do it. You would start to think about what are the x values. So maybe on my window I might set the window to be an x min to be 0, or maybe to be negative 10, and an X max to be 60. I tend to like to go to windows that are slightly bigger than my extremes that I put into my diagram. But the other option is to just do a zoom fit. Now the zoom fit is not always going to give you the best window, but let's try it on this one. So this picture shows a zoom fit, and clearly we can see now that there is a maximum. There's a maximum on this graph, and it's right there. So we would do a calc max. And I'm going to just look at the window setting. I'll keep this picture and we'll put the window setting up. So for this graph that we see here with our maximum visible, the window, the X min, is 0, and the X max, over to the right here, the X max would be 60 over behind there. And the Y min is minus 600, and the Y max is 624. So that's what I'm looking for you to put on the diagram in the packet. So we predicted a close range for the X's that would make sense, and what we didn't know is what the maximum value was. So now let's actually find that max value. So we're going to do a calc, which is above the trace button, max, and then we're going to put our little star to the left, and then we're going to put our little star to the right. You're going to hit enter, and when you do that, you're going to get the maximum value. And when you do that, you're going to get the answer at the bottom of the screen that says the maximum occurs when X is equal to 25 and Y is equal to 625. Now remember, X was the side, this is the side, and the Y, that's the area. So the maximum area is going to be 625, and the units were in inches. So the maximum area will be 625 inches squared, and I'm going to go back to the worksheet so you see how to answer this. So just going back to our beginning slide where we started, we had the given, we had the unknown, we had the equation, and then we substituted into the equation. So we're doing all steps of the guess model. So this was the equation step, given, the unknown, the equation. Then we substituted in, so we said that the area is equal to X times 50 minus X. That's the equation, and we put that into our calculator. And now we have to do the graphing window. This is a requirement of the activity because I want you to practice using your window. So we said that X min was 0, X max was 60. Y min was negative 6, just double check my calculator, negative 600. And Y max was 625, and there was, the axis was in here, and it looked something like that. And the important piece is that you show that what we did was we calculated that point at the maximum. So on your paper, you should be identifying the important point that you were calculating. Sometimes it's a max, sometimes it's a min, sometimes it's a 0, and then we have to answer the question. So finally, max, the last step is to solve. So what we're saying is that the biggest area is 625 inches squared, but the question says what are the dimensions, and that corresponded to a dimension of 25 inches, and then the other dimension, which we could calculate from our original diagram, and you can figure out from your perimeter rule, these were 25, and then this was going to be 50 minus X, so they're all 25. It turns out that a square is going to make the maximum area. So the dimensions, I shouldn't write it like that. Since X is 25, what we're going to say is that the length is equal to 25 inches, and also the width of this is equal to 25 inches. And that would be the answer.